This video is going to talk about angles and types of angles. So first let's get a definition down. An angle is formed by two rays that share a common endpoint. And the endpoint, the name of that endpoint is the vertex. So let's look at an example. A ray, by the way, is just a line segment that goes on and on forever in one direction. So I have to get here these plastic pieces. They're called angle legs. They're used to help teachers and students show angles. So I have snapped them together, which means they are coming together at this common endpoint, and we call this place where the two line segments or rays meet the vertex. So this is the vertex, and then this whole thing is the angle. It includes the two rays or line segments and the places in between. And the cool thing about angles is that they involve movement, or they involve opening up or rotation. All of those ways are ways we can think about angles. So check it out. If I close it like this, right now it would be closed. It's not even really an angle because there's no space in between. But as soon as I open it up a little bit, then we can call this an angle, and it's a small angle. The measurement, the distance, the amount that it has opened up is small, and so we have a name for small angles like that. They are acute, a cute little angle. And this angle will be acute until it reaches the point where it is called a right angle. And you might have seen a right angle before when you've talked about squares or rectangles. It's that sharp looking corner that we see on a square rectangle. So I'm going to open this angle up until it becomes a right angle. So it's acute, 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 all the way until right here. And this right angle has a special measurement too. It's called 90 degrees. So the amount that it's opened up is 90 degrees. All right, so then anything past this, past a right angle that's opened up even more, anything past that, as soon as it's 1 degree more, like 91, then it's called an obtuse angle. And those are going to be the bigger angles, bigger angle measurements. So I always say obtuse, a big obtuse angle like that to remind you what it means. So it'll be obtuse. So remember, this was right when it looks like the corner of a square rectangle, and then obtuse, obtuse, obtuse. It's going to keep being obtuse all the way until it opens up into a straight line like that. And then guess what that's called? A straight angle. Right here, a straight angle. That's pretty easy to remember. And so we would call this 180 degrees that it has opened up. That angle's opened up. So let's review it one more time. This would be a 0 degree angle. It's not opened at all. Once it opened up just a little bit, these would be acute. We can measure those degrees. It'd be less than 90 until it gets here. Now it's a right angle, and it has a 90 degree measure. By the way, we can measure that with a tool called a protractor that you're going to learn about a little bit later, how to actually tell how many degrees it's opened up. And then as soon as it gets over 90, obtuse, and bigger and bigger and bigger, obtuse, 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 until it is a straight angle. And one cool thing to know is that if we went all the way around, you actually can have angles that are bigger than that, and then they go all the way around. The number of the degrees in a circle would be 360. So if you maybe heard of somebody do a trick before and it was called a 360, that's because there are 360 degrees in a circle. It means it's gone all the way around. All right, so what we're going to do now is take a look around the school and see if we can find any angles. And we're going to be looking for acute angles, right angles, obtuse angles, straight angles, and we'll also maybe sometime point out the vertex and see if we can find that. Let's go. Hey, I found an example. Check it out. This is a document camera that teachers use in their classroom, and I realized that it has places that can move, and so those are the vertices. So check out this spot right here. It can bend right here. So if I bend it, then I've made an acute angle. Here's one of those rays and the other ray, and my vertex is right here. I can straighten it out to be a right angle. So now it's at that 90 degree, like the corner of a square rectangle. And then look, I can even make it into an obtuse angle, even bigger. So now this nice big open angle. And I found out a way to show a straight angle. Look at this part right here. It has a vertex, another place that it can move. This one's at a right angle, but if I open it all the way up, make it an obtuse, 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 all the way until it's straight, pointing out that way, now we have a straight angle. I think I got it straight. There we go. Now we have a straight angle right here. So this is cool. It can show all those kinds of angles. Oh, hey, Miss Thornhill, what you doing?
Oh, hi, Miss Prophet. I'm just cutting some things out.
You're using, you know what? I think we could use your scissors to show angles.
Oh,
let's take a look. What kind of angle? I see you have it only open a little bit right now. What kind of angle?
An acute angle.
Oh, you're exactly right.
Yes.
Do you think scissors can make a right angle?
Let's see. We need a square in the middle, right?
You did it.
Like that?
Yeah. I wonder if they could make obtuse. Do they go open really big?
Oh, look, they do.
Oh, wow. And you can even point to the vertex, can't we?
I can.
Yeah,
Yes.
right there in the middle
Right
where they
there
meet.
in the middle.
Could we make a straight angle with your scissors?
That's as far as it's going to go.
Yeah, no straight angle.
No straight angle.
Hey, thanks for showing us that example of angles.
Sure, absolutely.
So I realized that when you do a pull-up, there's angles involved. Mr. Watson's going to show us. So at first when he's hanging, go ahead, show us. At first when he's hanging, his arms at a straight angle, and then they go all the way to an acute angle. Check out his elbows right there. And then, awesome. Do you think you can show us a right angle with your elbows? Can you try?
How is that like? Let me see.
He's got to freeze at the right angle. Let's see if he can do it. There we go. Yeah, his arms at a right angle. Thanks, Mr. Watson. All right, Miss Salyers has got another example. So right now, what kind of angle is your arm making? A straight angle, right? It's all the way extended, and then she's going to bend it until she gets to a right angle, and then she can keep going to an acute angle. I love it. All right, so I was walking by and I saw all these ladies making breakfast, and I noticed an angle. Will you show us? Open up the refrigerator. Right now it's closed, but it's an acute angle, and then she opens it right here to a right angle, and then if you open it even farther, now it would be what kind? An obtuse angle. It's nice and big. So back to a right angle, and then acute, all the way to closed. Thanks for showing me that angle. No problem. Hey, check it out. What kind do we have here? If you said obtuse, you're right. Hey, Miss Bost.
Hi.
I noticed that you have some angles right here on your window. What kind of angles do you have?
I have some right angles.
Oh, that's super cool. Is it just one right angle?
So something that's super cool is because we have these intersecting lines right here, there are actually 4.
4 right angles in one place. That's so cool. Hey, why don't you show our friends at home how we can mark a right angle without writing the numbers? It's like a secret symbol.
Yeah, so
Or not so secret.
It looks like kind of like a little box, kind of.
Yeah, it might be hard to see, but it's just over and down, a little box right there in the corner. That's like a signal that means, hey, this is a right angle. Thanks for showing us that.
Mm-hmm.
Thanks for joining me on that hunt for angles. Now I want you to see where you can find angles in your house or neighborhood.